In class activity 12C, the Bermuda Triangle, two intrepid scavengers, Pat and Jordan, decide to rent motorboats to explore the lost treasure that is supposedly located at the bottom of the Bermuda Triangle. They want to maximize their probability of success, so they each take a boat, some metal detecting devices and compasses. Because their cell phones will not have reception, they must also take walkie-talkies, which have a range of 10 miles. 1, how might the two plan to coordinate their routes? Well, there's various answers, but you could say they decide to both head in one direction and each monitor one side. Pat watches starboard while maybe Jordan monitors port. We could also say, well, Pat and Jordan could separate and each travel in different directions until one finds the treasure, or they can no longer communicate with each other. Or they could try to travel in increasingly larger circles surrounding one spot or one hot spot. So there's various ways that you could answer that. Let's go to the next page. Objectives for the activity. You will understand that the law of cosines may be used to find information about an oblique triangle when the law of sines cannot be applied. You will be able to use the law of cosines to find the missing side of a triangle when two sides and the included angle are given. Use the law of cosines to create an equation relating to different rates. Next screen. 2. The boaters decide that the best way to proceed is to head in different directions, but keep in touch via walkie-talkie. In one scenario, Pat heads directly north at an average rate of 1.74 knots. That's about 2 miles per hour. And Jordan heads northeast at a 45-degree clockwise angle to Pat at an average rate of 2.6 knots. That's about 3 miles per hour. How long could they travel before they would be out of contact range? Remember that the walkie-talkies have a 10-mile range. Part A says they begin their planning by determining how far apart they would be after traveling 1.5 hours. Draw a diagram of their locations and include the distance that each has traveled and the measure of the angle between them. So let's scroll up a little bit. That's good. And just draw, let's see, a diagram. So there's my, I want to put my starting point at the bottom here. So I want to say start here. And we're going to travel that way, which we could say is north. And we're going to go 3 miles. And then at a 45-degree angle, we're going to be going northeast. So I'll put northeast here. And that is going to be for 4.5 miles. And this angle in here is our 45-degree angle. Okay, so let's go to part B. That was part A. Part B says the triangle in part A includes the measures of two sides and the included angle. The treasure hunters need to know the measure of the third side, which represents the distance between them. Explain why they cannot use the Pythagorean theorem or the law of sines. Well, the Pythagorean theorem only applies to right triangles. So let me put that here. Pythagorean theorem only applies to right triangles. And the law of sines requires knowing either of the measures of two sides and the angle opposite one of the sides, or the measures of two angles and the side opposite of one of those angles, and we don't have that. So we could say the law of sines, what do we need? We need the measures of two sides and an angle opposite one of sides, or we would need the measures of two angles. And side opposite one of the angles. There we go. So law of sines we can't use. Let's go to the next screen. It's part C. It says this situation requires that we use the law of cosines. The law of cosines is a formula relating the three sides of a triangle and one of the angles. It may be written in various ways depending on which sides and which angles are known. And there's three different ways that it can appear. And they're listed here with a picture of a triangle. So in the current case of the boaters, the length of the two sides A and B are known, as is the measure of the included angle C, which is the angle between sides A and B. Use the law of cosines to solve for the distance between them, C, as described in part A and shown in the diagram below. So let me show you the diagram below. Scroll down there. And so we have I'm going to use this version. Whoops, I do not know what happened. Let's erase that. Go back to where I thought I was writing and try to write again. Let's see, what do we do? C squared is equal to A squared plus B squared minus 2AB times the cosine of angle C. So that's the version we're going to use. And let me show, it's right at the top of the screen there. It was the first one that was listed. So we just continue. I'm going to put some information in here. So that means that C squared is going to be equal to 3 squared plus 4.5 squared minus 2 times 3 times 4.5 times the cosine, and that's going to be 45 degrees, which is angle C. So if we calculate all of this and then take the square root, because I want to know what C is, not C squared. So I take the square root and we take the positive square root and we end up just about 3.19, and that is in miles. So we found out the distance between them, which we're calling C, is about 3.19 miles. Next screen. Part D says, why does this formula work? Well, we can refer to the diagram that's listed here, and we can fill in the blanks to complete the steps in the proof shown below. Part 1 says, draw line segments H and K and 4.5 minus K, where H creates a right triangle from Pat to the line segment from point S to Jordan. K is the length from point S to where the H intersects the line from point S to Jordan. So that's interesting. Let's put some information here on this. Let me just draw a line right down like this here. And it's a right, we have two right triangles here. So we have all the information, or much of the information here. This is what we're going to call this vertical line that I just drew. I'm going to call that H. This piece I'm going to call K. And then from, not the middle, but the point where the perpendicular H drops down and intersects that line segment where K is, this is going to be 4.5 minus K. All right. So number 2, it says the cosine of S equals, well, the cosine of S, we're here at S. So we're going to take the adjacent over the hypotenuse. So that's simple. That's going to be K over 3. So if we arrange this little equation here, it's presently solved for the cosine of S. But if we solve it for K, what we're going to get is K is equal to 3 cosine of S. Okay, let's do the same thing for the sine. The sine of S is going to be H over 3. Okay, it's just a definition of sine. We're still using S as the angle. So if we multiply through by 3 to solve it for H, we get 3 sine of S. Part 4 says using the Pythagorean theorem, we see that c squared is equal to 4.5 minus k, that quantity squared, plus, and we're on the other triangle, where the hypotenuse is c here, and that's going to be, let's see, to finish this here, we need h to be squared. Substituting the formulas from steps 2 and 3 into the equations from step 4, we get, and it's listed right here. That's just a substitution. And if we expand this and then simplify it, so I'm going to show you it's already been worked out for you. Let me go to the next screen, put that back, and we end up with the c squared equals 3 squared plus 4.5 squared minus 2 times 3 times 4.5 times the cosine of 45. And there's a better picture of the triangle we were drawing, or I drew one on the previous screen. Let me show you what that is. It is right there. Okay. Let's go on to part E. Part E says, in order to solve the initial issue from question 2, we have to solve the value, or for the value of t, the amount of time before the two motors are more than 10 miles apart, as shown in the figure below. Create a diagram and relabel sides A and B with algebraic expressions to determine the distance covered from start for each of the explorers in terms of t. Side C should also be relabeled as 10 miles. Okay, so we could do, let me just do another picture right here. So I have that, and this is S. There we go. There's north. There's northeast. C, it says to call that 10 miles, so we'll do that. And here's our 45-degree angle. Now the 3 miles from S to Pat, so we're going to relabel that in terms of T. So that would be 2T. And over here, the 4.5 miles is 3T. Create a diagram and relabel sides A and B with algebraic expressions. Distance covered from start. Okay, so we did that. Let's go to part F. Next screen. Part F says use the law of cosines and your diagram from part A to create an equation to solve for t. And we want to show our work. Okay, so we could say that 10 squared is equal to the quantity 2t squared plus the quantity 3t squared minus 2 times 2t times 3t times the cosine of 45 degrees. So if we just start doing the arithmetic and expanding this, we get 100 equals 4t squared plus 9t squared minus 4 times 2 times 2 is 4 times 3 is 12. So we get 12, and then t times t is t squared. Again, cosine of 45 degrees. And it's going to keep working and expanding here. 4 and 9 is 13, so we get 13t squared minus 12t squared. And the cosine of 45 is going to be, remember that's root 2 over 2. So we're going to multiply that there. If we factor out t squared common, we can write the 13 inside the parentheses, and then minus 12, and then root 2 over 2. Close the parenthesis. And I'm solving this for t, so we're going to write t squared is equal to, you have 100 over this parenthetical expression, we're writing it here, 13 minus 12 times root 2 over 2. Scroll this down a bit. There we go. So we end up with t is equal to, let me get the plus or minus, the square root, and it's everything I just wrote on the previous line. So let me put that here, 100, and then 13 minus 12 root 2 over 2. And we can discard the negative solution. There's not going to be a negative, realistically. We can't take that, so we're going to keep the positive solution, and if we enter this into our calculator, we're going to find that t is about 4.71 hours. Oops. There we go. Let's go to the next screen, and part G says interpret your answer in the context of the original question. Well, in terms of the original question, we could say, who were they? They were Pat and Jordan. Okay, they can travel in their boats. You say at their individual paces. It's in their respective directions. Respect. I can't write and talk at the same time. Respective directions for, and here's the 4.71 hours that we just found on the previous screen, and that would be before they lose contact with each other. All right, so let's go to part 3, or number 3. Being a careful planner, Pat proposed an alternate scenario as follows. Suppose that Pat heads north and finds the treasure after traveling for 4 hours. We want to determine whether, if Jordan heads southeast, that would be 135 degrees clockwise from Pat during that same time frame, will Pat still be able to contact Jordan? Part A, draw a diagram of the situation showing the lengths of the 2 known sides of the triangle that represent the situation after 4 hours. Assuming that Pat traveled north at the given rate of 1.74 knots, about 2 miles per hour, while Jordan traveled southeast at a rate of 2.6 knots, that's about 3 miles per hour for that same time period. Make sure to include the measure of the angle between the 2 known sides. So we could draw that. Let me just scroll down here and okay. I'm going to start here again, and that would be north. And then if I go, let's see, extend that a bit, southeast. There we go. This is going to be 8. This distance will be 12. And I'm going to connect these with a straight line. There we go. And that is C. And the distance, or not the distance, but the angle here is 135 degrees. And we're rotating. I don't know if that's, let me try to draw a better arrow than that. We're rotating clockwise. Next screen. Part B, determine how far apart the two boaters would be after 4 hours under this new scenario. Well, we can apply the same that we did earlier. So we can write 8 squared, c squared equals 8 squared plus 12 squared minus 2 times 8 times 12 times the cosine of 135 degrees. And if we crunch all these numbers, take the square root of both sides, we're going to see that c is equal to, and I'll put an intermediate step here, 64 plus 144 minus 8 times 12, and then double it, we get 192. And then cosine, if we calculate that, it'll be a negative. It's in quadrant 2 and about 0.71. And we're going to take the square root of that, both sides actually. So then we end up seeing that we get about plus or minus 18.54, and this is in miles. Next screen, part C, under this scenario, would Jordan be able to hear Pat over the walkie-talkie? No. Justify our answer. Let's see, no, we could state because they would be, how far was it? 18.54. Yes. 18.54 miles apart. This is farther. Their walkie-talkies can reach. There we go. And that's the end of this video. Thank you.